if someone could just let me know that you are now seeing the presentation, that would be great. Anybody?
Yep.
Okay, great. Great, thanks. Thanks for helping. Okay. All right, so this is specifically directed toward attorneys that deal with construction defect litigation, but I know that several of you are not attorneys and have other reasons to be participating in this webinar, and I think that's great because a lot of various kinds of people need to be able to read construction drawings, architectural drawings, I should say, and it's very valuable to be able to read the drawings if you're a real estate person or you're just doing your own architectural project. Being able to know what you're looking at is definitely helpful. So what I'm going to go through here today is a rather extensive but non-professional approach to reading architectural drawings. So let me start by introducing Eugene and myself. Eugene is Eldon. He goes by Eugene. He is unfortunately not participating today, but Eugene owns Advise and Consult. He is a longtime home builder, remodeler, restoration contractor, and as a builder, he understands deeply all of the issues involved in actual construction and where construction defects occur. I am one of several advisors around the country in various cities who assist with architectural consulting, report writing, as well as deposition and court appearances when it's needed. As many of you probably know, the vast majority of cases never actually go to trial in the court, which is a good thing, but that's my job, is to provide very truly objective analysis of what occurs. Of course, construction defect attorneys also understand that although there is such a thing as objective, there is also a component of theater in doing construction litigation. So I understand who I'm working for, but nevertheless, it's my job to be an objective outside observer and give you the information that you need, and then release it to the opposing attorneys for their use. So know that I'm not going to toss something out into the universe that will put you in a tough spot. But at the same time, I will advise you when I need to be honest. So, Advise and Consult, I'm just going to read, as a company of experts who have been involved in over 200 actually more than 200, and I think that that's probably a few years old. So, everything from arbitration, mediation, deposition, courtroom experience, litigation support. We do a lot of work for insurance claims. We also do estimating. Yes, hello? Sorry, thought someone was asking a question. We do quite a bit of cost analysis for repair and replacement values of construction defects. So that's Eugene. This one is me, if I can get it to advance. There we go. I am the owner and principal of Folio 42 Inc., which is an architectural firm that I formed after having owned my own firm for about 20 years. I sold that firm about 3 years ago and have since, so I won't say semi-retired, but I've been taking on a variety of different kinds of assignments, and that's why my firm is called Folio, as in a portfolio career. So I don't like sounding self-important, but just as a way of informing you about who I am registered with the NCARB for practice in all 50 states and Canada. I've been working at this as my single and only career for over 35 years. It scares me when I can say something like that because it means I'm old, but anyway. I worked several years in New York City, designing buildings with Kohn Pedersen Fox and C.F. Murphy and Helmut Jahn, which are also still internationally known firms. I worked in Japan for 5 years as the leader of a design team for a large construction company. So I've had experience in construction process in multiple countries and continents. And for the most part, what I do is large-scale corporate and commercial projects, but I have done quite a bit of single-family work and a variety of retail and such other projects. So I do have experience with pretty much any kind of construction project that you might have. I am currently teaching at Berkeley and the California College of the Arts in business practice for architects. And I've done, as it says, construction defects, claim cases, forensic analysis, and I can help you if you need it. Okay, so reading architects' drawings is a skill that most architects spend years in school to learn, and by the way, I should also have said that they spend years in internship. There's a 3-year internship requirement for licensure in the United States. So at the minimum, 6 years of specific architectural schooling. So obviously in one session, you're not going to be able to know everything that most architects know because they continue to learn. We all continue to learn as we go through our career. But you should be able at the end of this session to navigate through a set of drawings and understand basically what you're looking at, how to get to different parts of the drawing set, and understanding what the relationships are between the different portions. The issue about design details is a big challenge, especially for you folks. Detailing, and we'll get into this later, but detailing is a major component of architectural design as well as contractual and litigation issues. So reading the specifics of details in a set of architectural drawings can be a big challenge for someone who hasn't spent a lot of time doing it. But I will walk you through some of that, and there is a follow-on seminar offered in this series that allows you to study much more closely how construction details work, which is where the vast majority of construction defects claims occur. As you probably know, those of you who are doing construction litigation, probably 80% of construction cases involve water, and water infiltration into buildings is all shown in the detailed drawings. So I'll show you how that works in a little while. So architectural drawings, everybody always uses this term blueprints. It's sort of one of those things like people saying Frisco or San Fran when referring to the city of San Francisco. People who sort of know don't use the term blueprints anymore because blueprints were in fact blue. This is a drawing of Grace Church in Utica, New York. The printing process was one that used an ammonia, and back early in my career, we used to still have blueprints, and I would make copies in this horrible ammonia machine and breathing in the ammonia, so maybe that's why my brain doesn't function entirely correctly. But anyway, that's why people call them blueprints and have called them blueprints in the past. And as you know and you've seen, today's drawings are copied using the typical Xerox process. So usually people will say the plans or the architectural drawings. Using the term blueprints with architects is one of those things that makes the hair on the back of their neck stand on end. So that's just a minor little side point to keep in mind. Okay, on to the drawings. So there are 3 critical types of drawings in architecture: plans, sections, and elevations. I'm going to describe those in much more detail. There is a fourth, arguably four, I say. The fourth is axonometric and perspective drawings, and I will explain those as well. So any of these four types of drawings can be used in an architectural construction set of drawings in different contexts, depending on what it is that you're trying to show, what you're trying to convey with the particular type of drawing. So, and I say at the bottom there, these are all highly abstracted ways to see a physical object. So it's important to keep in mind that these are not images that refer to something that you would typically understand by looking at a building or a room or a space. An example of extremely complicated design drawing, and I'll talk about that as well, is what I'm showing here. This is plans, elevations, sections, perspectives, axonometric, all of the drawing types shown in a single drawing as an art piece. And hopefully and fortunately you will never ever see one of this kinds of drawings, but this is an architectural drawing. There are several architects we refer to as paper architects in the field that create drawings like this and sell them in art galleries. So it's an interesting side field, but hopefully you will never see something like this. Hang on. Okay. So the similar version of that kind of drawing, but in actual day-to-day use in architecture, is referred to as preliminary or design or presentation drawings. And these are drawings that are used in preliminary design phases prior to developing the detailed construction drawings. And they generally don't include technical information like dimension strings, notes, keys, and you'll learn about all of those things in a little while. But they are meant to convey the feeling, the atmosphere, the colors, the textures, any of the sort of tactile aspects of a building or a room or a design. And these are, generally speaking, non-contractually binding drawings. So typically the contract and the potential litigation issues come after all of the design drawings have been produced and presented to the client and agreed to. So many architects, not all, but many architects will ask their clients to sign the final design drawings that are used to move on to the detailed construction drawings, because they want to be certain that the client has carefully thought through all of the design elements and then move into the detailed drawings so that there aren't a lot of changes. Changes during the construction drawings phase is one of the major bugaboos of the architectural profession. We hate it when clients make changes during the construction drawings, because you'll see they're very complicated and they have an extensive number of internal references back and forth, and clients frequently don't understand that in a construction set of drawings, if you ask for a change, it doesn't change just one drawing. It changes probably 6 or 10 drawings, and you have to chase through all of those changes in order to be thorough about making the change. So the design drawings are the fun stuff, the stuff that you see, pretty pictures in various kinds of presentation scenarios, and that's what this is. So then there are the construction or contract or detailed drawings, and these are the fully developed versions of the design drawings after, as I said, after the client approves the design. So they will have, hopefully, and if the architect is a thoughtful, contractually oriented architect, he or she will have asked for a signature on the design drawings as approval, and then move into these kinds of detailed drawings. And the detail in these drawings is, again, highly abstracted, and that is why most people, average people with no architectural background or education, find these very difficult to understand. So what I'm going to try and do here is go through all the various kinds of elements that you find in a construction drawing set, and walk you through how to navigate among those drawings. So these are just two examples of drawing sheets from, there are two different projects, and shoot, I meant to delete all the names and project names, firm names and project names, but I failed in this one, sorry about that. But anyway, these are two different types of drawings. Reading architectural drawings also has major implications in these different phases of the design. So, and each one of those phases, as I say at the bottom, another session will explore the complexities and legal issues in each of these phases, and each one has its own legal complexities that could bear on a construction litigation case. Typically for the architect, there's a first meeting, introduction, then the preliminary design sketches, which are sort of some of the drawings that you saw earlier. Schematic design also sort of flows from that into maybe a little bit more detail, corrections to the original design sketches, but still non-contractually binding. Design development is where typically all of the different subcontracts of the architect, the mechanical systems, air conditioning, heating, HVAC we call it, electrical, plumbing, all landscape, civil engineering, all of these are coordinated during the design development phase, so that when you pass from design development into construction documents, all of the disciplines know what the project is and have agreed on how things work. I will talk about that in further detail as well. So after construction documents, typically it'll go out for bid. Value engineering and bidding, negotiating, and permitting are pretty much all done concurrent. Value engineering is what we call the words we use to refer to slice and dice, take stuff out because the whole thing came in too expensive and we need to simplify the design or make changes or substitutions. So that is the place where we know in advance that we are going to have to make changes, not because of the client's programming issues, but because usually, almost always, because of cost. And then the construction phases, which is where you folks live for the most part, pre-construction meeting with all the constituents, the actual construction phase, and then the punch list and project closeout. I will say that this entire process is the true professional, probably large-scale commercial process. The smaller scale projects like single-family homes, like commercial interiors, and various of those sorts of projects will very likely squish some of these processes together. So that's something to keep in mind depending on the type of project that you're working with and type of client that you're working with. Okay, reading the drawings, which is the real meat of why you guys are here. Thank you for your interest in this, by the way. I really do think that this will equip you in a way that many attorneys are not equipped to be able to understand what you're looking at when an architect comes to do a construction litigation advice. So again, the three primary drawing types, remember that the fourth type tends to be more of a presentation tool. It's perspectives and axonometrics, which I could explain separately. But the plan, section, and elevation are shown in various ways depending on the type and scale of the project. So this is, interestingly, I just stole this particular image because it's a perfect example of one sheet, which is on the right side here with the big thick red line around it, a single sheet that represents all three drawing types. So these drawing types, and then I've separated them out to the left on those three smaller boxes. The three drawing types are represented here. You all are mostly probably familiar with plans, which is the two drawings in the full sheet there, the two drawings across the bottom. Those two drawings represent a ground floor and an upper floor. And the way that you know that is by looking at the section and the elevation. So the section, it says sectional elevation in the upper left of that sheet, and you can see it enlarged to the left below. The sectional elevation is a slice vertically through the building, and so it cuts through materials, and I'll explain this a bit more shortly, but it cuts through materials and then you see what is beyond. So that's a sectional elevation. A simple straight elevation is just as if you were standing in front of the building and looking at it, at a side of it. Now, the important thing here is that, as I've said a few times already, these types of drawings are highly abstracted, and in fact, an elevation is something that the human eye cannot see. It's a flattened representation of a building face, which, because it's flattened, allows the architect to identify clearly the relationships between different parts of the building, the dimensions, widths and heights of various things across the facade. But you can see, for example, that the fireplace, if you look at the plan, the fireplace is at the back of the building. But then in the upper right corner, the west elevation shows the fireplace chimney as if it's in the same plane as the elevation of the building, which in fact it's not. Again, you would never see this with human eyes. You would be standing in front of the building and that chimney would be quite far away from you and you wouldn't actually see it. So that illustrates why elevations are important, because, for example, you want to show how far above the peak of the roof line that chimney occurs. And you can see there are dimension strings, and I think probably most of you are familiar with dimension strings. We call them strings because they refer to various relationships of dimensions. So, for example, on the first floor plan on the lower left, there are two dimension strings to the right side. Typically the furthest away is the larger aggregated dimensions that refer to larger components of the building or the detail or the section, whatever it is. And then smaller, the next string in breaks those large dimensions down into smaller specifics of the particular building or space. Oh, someone is waiting to get in. I apologize to McKay and Alicia. Apologies to McKay and Alicia for leaving you hanging there. Okay, so let's talk about plans in specific. Plans are, again, a highly abstracted slice, and basically what you're doing is as if you were taking a machete and slicing right through the building. And the important thing to know about plans is that slice where you run that machete across the building has to be 36 inches above the floor. And the reason for that is that window sills are generally 36 inches or lower, so that when you draw a plan, it will also represent where the windows, the doors, and various kinds of openings are in the building. Now, the plan that you're seeing in the upper right is for the whole building, and we've just taken a slice right through that building. In the lower left, again, probably pretty abstract, but I tried to choose something that was easier to understand. This is a detail section of a door, and what you're seeing here is the door with the two handles, a handle on each side of the door, and how the door swings. So, for example, you might if the dashed lines were not there showing how the door moves, you wouldn't necessarily know where the hinge was and which direction the door opens in. And that can be very important for things like ADA clearances and hallway widths and passages where the door could swing out and hit somebody in the face. Frequently comes up with issues like storefront designs, because you cannot open a door out into a public way. So that's why many of you may have seen storefronts that have a kind of a little recess where the door is, so that when you open the door, it's not swinging out into the sidewalk. So various kinds of plans, and we'll be looking at more of those in a short while here. Okay, then we're talking about the three types. Now we're on elevations. That was plans. Elevations, again, are very abstracted, flattened views of things. And I've got three examples here. The large one on the right is to help you understand the differences between a perspective and an elevation. So the perspective on the bottom, there's a lot of guidelines here that were used to construct the perspective, but if you're able to ignore those, you will see that the perspective of these two sides of the building that you're looking at show you in much more realistic way what the relationships actually are of all of the three-dimensional pieces of the building. Perspective is actually something that was discovered, believe it or not, by a gentleman named Brunelleschi during the Italian Renaissance. Nobody had known that before. And so paintings that were drawn before the Renaissance involve flattened images of things, but nobody actually knew how to represent something in a more accurately three-dimensional fashion. So what you're seeing on the bottom there is the two faces of the building in a perspective, and then right above it, you're seeing the two flattened elevations of that three-dimensional object. And a good way to understand this is that if you look at the columns that are on the lower left face, right by the stair of that perspective drawing, you can see that there are columns and then an open porch directly behind them. But when you show that in the elevation on the upper left, there's no way to understand that those columns are standing away from the face of the building unless you see the other elevation to the right, which you can see depicts an open porch to the right side of those columns. So that pair of elevations is important to be seen together because, as I say, typically a perspective drawing is not shown in a construction drawing set, but elevations are. So it's important to be able to understand those relationships between different portions of an elevation. Now, a different kind of an example of an elevation is in the middle here. It's I think it's a Russian train station, if I'm not mistaken. And what you see here is a large portion of the building facade in elevation, and then a highly detailed segment of it, which helps the builders understand what all of the construction detail are going to require. So, that detail, if you look at the detailed elevation, you can guess just by looking at it that all of those elements in that elevation are not in the same plane. They occur in various distances away from the viewer, but the flattened version allows you to understand the architectural relationships between those things. In the lower left, a similar example. This is, you know just by looking at this that this is a spiral stair going to a landing on a mezzanine on a second floor, but that's obviously not what a spiral stair looks like. This is drawn for the most part to show how far vertically each step is from the next step, and along the left edge of that detail you can see that there's a clear dimension string identifying the thickness of each step and then the distance between each step. So that's the purpose of that drawing. It's not meant to represent how elegant the thing is or what it is. It's just giving you specific information that you need to know in order to understand the detail of the stair construction. Okay, then our third drawing type is sections. And again, abstracted, flattened views of the vertical planar cut through a building or object. This is one of the most heavily used drawing types in construction drawings, and you'll see more why that is the case further along. Drawing on the right side is an architectural detail. I know that this is where your guys' eyes all glaze over, but I'm going to, further along here, I'm going to discuss how to look at an architectural detail. And the architectural details are use a lot of symbols, a lot of words, symbols for different materials, and so those are the things that you may never come to necessarily understand in detail, or you might over time. But if you look at the middle and the left section details, the one in the middle shows the same wall that is depicted in the detail on the right, but that wall is shown in the larger context of the whole side of a house. So here you can see how the relationships between the floor, the foundation, the wall, the roof rafters, and the slope of the roof all relate to each other. And then the detail on the right gives you a specific location of one piece of that construction. And I'll show you how that works when you move through a set of drawings, and it's not intuitive, so I will show you that here shortly. So again, architectural drawings can be any of these plans, sections, elevations, and you have all of those here depicted on this slide. Details are usually sections, but they're also sometimes plans, as in the lower left here. You can see it's a typical wall system plan view. So it might be any of a variety. Here are some elevations, including a detailed elevation of how a stair bracket is made. That would be something to inform the costing that the contractor has to give for how much it's going to take to create that thing. Okay, now let's talk a little bit about how you actually move through a set of drawings to get to information that you need. Okay, there is an AIA standard format for drawing sequences, and the drawing index, which I'll show you in context on a cover sheet of a drawing. The drawing index is what tells you where all of these things are. And the standard sequence is generally, again, for a larger commercial project, you'll find these, maybe not quite as much on smaller projects, but N is just information, abbreviations, notes, ADA details, all the standard information that goes into every project. Those sheets, just as an aside, in an architectural firm, those sheets are virtually never changed. They're just, boilerplate sheets that go in. C is civil engineering sheets. This particular index that I'm showing here does not include civil engineering, and I'll show you why that is. Architectural, which is the meat of what you folks are dealing with, or interior design, which you spend a lot of time working with as well. And then structural, mechanical, electrical, plumbing, and the poor landscape architects get last place. So any or all of these may be included on any given project. And for example, the architectural set includes all of the types of drawings that we've talked about up till now, but so does the mechanical and the plumbing and the structural. They all use the same drawing conventions, and each one of their sets is kind of a freestanding element, but they all interact with each other, and that is what we in the industry refer to as coordination. So coordinating drawings and the contractual responsibilities is a big issue in construction litigation. And the reason for that is that some of these consultants are directly contracted by the owner, some are contracted by the architect. And you can see, for example, civil engineering is contracted by the owner, but structural is a sub-consultant of the architect. So the architect carries the liability for all of that structural, mechanical, electrical, and plumbing. The owner, however, doesn't carry liability for all the rest of them, the civil engineering, the architectural, all of that, and I say, who coordinates each consultant? Guess what? Architect, 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 and architect. So unfortunately, we get to live with all of the liability for the coordination of all the consultants. Now, that's not to say that certain particular consultants won't be sued directly, because they frequently are. If there's a structural problem that the architect missed, but it's in the structural drawings in error, then the liability does move in proportion to the structural engineer. So that's something to keep in mind. You may or may not want to work your way past the architect in your lawsuit or your case, but in some way or another, everything eventually does flow back to the architect, particularly coordination issues, and I will show you what that means in a minute. Okay, so here's the meat of what I live in every day when I'm doing construction drawings. And this, I know, is where your guys' eyes typically glaze over, but understanding how each drawing interacts with the other is very important in your ability to understand, not necessarily to understand the specifics of how something is put together, but to understand how you can move through a drawing and find what you need to find. So what you're seeing here is a plan and a section, and you'll see a bunch of different symbols all over them. And if you look to the left here, these are typical industry standard accepted keys and symbols. So a key basically is something that directs you elsewhere in the drawing set to find a specific thing. So for example, detail keys on the right, on the drawing on the right, you'll see that there are these dashed circles and rectangles that are identified by a little tag that goes off to the side. So you'll see on the rightmost one, that little detail at the top corner of a framed member is identified as detail 1 on sheet A 5.9. So that helps direct you forward, whereas interior elevations and wall sections or section cuts are identified by these dark arrowed circles. And again, the same idea. So on the plan drawing in the middle here, you'll see a section in the lower right-hand corner. You'll see a section cut called B5. That is identifying detail B on sheet 5. This is a smaller project, obviously, because it's just a number 5. So that means there are less than 99 sheets in the set. Whereas on a larger commercial project, your detail keys will identify themselves with numbers like A 5.9 or A 7.12, which are all numbered by those numbering key systems. So section cuts, detail titles. Detail sheets, when you get into the sheets covered with little different details, all of those will be identified in separate little boxes, and you probably have seen that. Each one of those boxes is one of those details. So that's how keys and symbols work, and you'll get a little bit more of this in a minute. Okay, so here we are. This drawing in the upper right is the same drawing we were just looking at, and I'm just highlighting 2 of the detail keys that you're seeing identified there, and you can see how you're directed forward to those drawings. On the lower portion, the 2 drawings here are a building plan and 2 sections. Let me actually go back here. So you remember here on the bottom left, section cuts identifies where a building section is cut. So in this drawing, you start at the large scale of the whole building, and you identify 2 section cuts. So here's section 1 and section 2 on sheet A 04.10. And you get to go find that sheet if you want to see the section. So here's a section of they're not the same building. I couldn't find a building plan and section of the same building, but the idea here is that if it's detail 1 on sheet 04.10, you're cutting the section through that building and you're looking at the section detail on the right, building section, and it's detail number 1. So that's how you move from that large scale of the building down to more specificity. Okay, so how you navigate through all of this mass of information. This is a building that's actually under construction right now that I designed, something I'm actually quite proud of in Los Angeles. It's a homeless and transitional housing complex made out of shipping containers. It's all upcycled shipping containers built in a modular factory. So those aspects of this building are not pertinent to this discussion. It just happens to be a building that I have the renderings and a full set of drawings that were just recently produced, so that's why I'm using it. But here you see, again, a presentation drawing. This was done for the final presentation right before the clients signed to approve the whole design, and we had been through months and months of design on this. Coordinating structural, you can see that there are diagonal braces that were what the structural designer required to resist the earthquake forces of the building. There's an elevator there that has the colored blocks on it. That elevator also had to be coordinated with vertical dimensions so that when the elevator stopped on the 2nd and 3rd floors, the elevator platform and the balcony were at the same height. So all of that also is required to be coordinated by the architect. So I'll get into that detail, but this is keep this visual picture in your mind of this building. It's a long, skinny building, a typical Los Angeles type of a building that sometimes are called dingbats. If any of you are in Los Angeles, I'm not sure if anybody is, but the dingbats are basically a long, skinny building that runs most of the depth of the lot. So that's what this is. It's sort of a dingbat model of a building. Okay. So this is the drawing set for that building. And what I want to do is highlight specific elements as we go through here so that you can see how to move through a set. Because the basic approach to understanding architectural drawings is that you go from the macro to the most micro. And the way you navigate through that set is to start at the largest scale and then to move your way down to smaller and smaller scale details. So sometimes you have to go backwards from a detail back to a larger scale drawing because you want to see how that detail relates in the larger context. So, for example, here you may see a building section as you did it. Actually, let me go back one more. So here you see a whole building section, and these two details, which I'm showing in the next slide, are here. But for whatever reason, you may need to understand the relationship of those two details to the larger context. So you would go backwards to look at the section. But essentially, you're moving from the large scale to the small scale. So here is the drawing index that we talked about. Most of the information on the cover sheet is specifics of which building codes you're complying with, the names and phone numbers of the various constituents of the project, the architect, the various consultants. Project location is something that's always required by building departments around the country. That's consistent, so you have to identify where the project is. And then the first N sheets, and you can see in the lower right-hand corner, AN1 and AN3. These are the architectural information sheets, AN1, AN3. And here on AN1, you see general notes, which do vary by project. Most architectural firms have a set of standard general notes, and symbols, abbreviations. Then on AN3, all of the standard ADA details for compliance with Title 24 ADA requirements in California. ADA is national, but ADA is part of the Title 24 in California. Okay, so moving through the set. A1.0 is nearly always the sheet number for the main plans, which is where you get the information about how to drill down from the larger scale to the smaller scale. So the origin of every key in the entire set is somewhere on these drawings. And this is at the largest scale. You can see it's a 3-story building with an elevator shaft. And if you look at that sheet, you'll see it's a 3-story building with an elevator shaft. That view is looking from this side of the building, okay? Now you've learned that there are different kinds of keys here. This is an elevation key. This one is a section key. You can see it cuts all the way through the building, and there's a pointer that tells you which direction that section cut is looking. And you will go from the main plan as the first point of contact to one of those sections. Okay, so here's one of those plans. And what I'm showing you is the elevation key, which identifies this long elevation. There's also an elevation key here for the shorter elevations. You do all 4 elevations in every set of drawings, or more if it's a complicated shape. You may need several more sections. But this elevation, which is identified right here, you can see this leads to this sheet. And then, well, let me see, I want to look at the elevator and coordinate, make sure that the elevator cab platform meets the height of the horizontal walkway. So I'm going to look forward from this section cut to the section of that portion of the building. Now, obviously, I wouldn't want to look at this section cut if I want to see how the elevator is constructed. I want to look at this one, see how the elevator is constructed here. So here's the elevator shaft. Here are the exterior walkways, and then the interior of the units. And you can see now we're starting to drill down into finer and finer detail. Here's a detail of a whole wall section, which is also one of the very standard types of drawings that you'll find, which show you the relationships of all the different components of an entire vertical wall. And you'll see there are also detail keys here that lead us to other things. And if you get to the point where you can understand what a parapet is and how it needs to be drawn, you'll be able to get to that. So let's start with this one. It's detail 2 on sheet A 4.1. So you're going to go from there, and my arrow goes off this page onto the next page. So here we are now at detail 1 on sheet A 4.1, and we're looking again at that portion, that section of this piece of the building as an entire wall section, so that you can see how each of the different elements interacts with each other. But then you're very likely, if you're dealing with a construction defects issue, this is going to be something that really is useful to you as a guide to point you to the specific large scale details that you need to look at. So for example, on the foundation element, you may have discovered that one of the major construction defects is water penetration at the foundation line. So you're going to want to find your way to this detail, which identifies how the building sits on the foundation. And you can see it says concrete footing, refer to structural drawings. So the element of the foundation and how the building sits on it can be very important in water penetration issues. Similarly, the parapet at the top of the building, and you can see I'm directing you here from the parapet detail to that actual detail drawing on 14A 9.0. And here we are at the detail, and an even closer look at that detail drawn because the specifics of water penetration, architects think about water every single day, all day long. In fact, a funny little anecdote. Frank Lloyd Wright was famously known to have said to one of his students, "You will know you are truly an architect when a client calls you and says, 'It's leaking.'" So that is really actually quite true in my profession, in our profession. So you're going to look at very fine detail of how flashing is attached, and again, you're not going to know what many of these elements are, but you'll know how to get to the detail of the parapet if you're talking to an architect on the phone or in a Zoom meeting, so that you can identify what drawing you're looking at, and you can say, oh, we need to look at the parapet detail that's on detail 14 on sheet A9.0, and the architect will go right to that drawing instead of working his or her way, all the way from that plan, the first plan, to all the way down to drill down to this specific detail. So that's something that can be very useful for you. A note on notes. Verbal notes in architectural drawings, the presence or absence of the note is almost invariably a component of a construction dispute. So for example, here we say metal deck and metal deck support refer to structural drawings. So we don't design the structural component that supports the metal roof deck. We just talk to the structural engineer and say, okay, what is this L-shaped component? How thick is it? How heavy is it? How long are each leg of it? So that says refer to the structural drawings. Now, if it didn't say refer to the structural drawings, you wouldn't necessarily know that somebody had calculated exactly what weight was going to sit on that angle and whether that was sufficient or not. So other elements like, for example, continuous roofing membrane. In drawings, typically you don't include information about the manufacturer or the specific specifications for that element. We're running out of time, so I'm going to start moving a little faster. So the reason that written specifications are so important is that those items that are identified as, for example, continuous roofing membrane, will appear in the specifications, which can take two forms. On a smaller project, you're going to have a sheet spec, which is what is here on the left, and you can see there are a bunch of different sections, and in those specifications, you'll find manufacturer specifications. So you'll say, and generally it will say a manufacturer or equal, because the contractor can choose a different manufacturer as long as it meets all the requirements of the original specification. So, so that's a sheet spec. The three sheets here to the right are for a synagogue I designed, and there's a very detailed table of contents. This had a lot of specifications, and it comes in the form of a book, and that book can be 2 inches thick for a project like this synagogue, or literally 3 volumes for a high-rise building. So all here is the spec you're seeing for the vinyl composition flooring. That's what we call, what do you call that in normal English? I forget. It's the square tiles, vinyl tiles on the floor. So very detailed, gives specifics about how to install it, materials, and the acceptable products. So it's a fairly detailed piece of information. The master format book form is a standard format created by the CSI, which is the Construction Specifications Institute, and this index, starting on division 00 and all the way through to, you don't see the entire list here, it goes through 80 some, I think 84 specification sections, many of which you won't use on any given project, but you will use many of these, and they will be found based on those sections. So here we have section 09, 65, 19. So that's section 09, which is finishes, and then the subsection 65 and 19 is specifically for vinyl composition flooring. And then, very important for you all in legal cases, you cannot make any legal case without the entire RFI, RFC, SK, and field instructions manual. And what that is once construction begins, most people think, oh, the architect has drawn everything in the building. It is physically impossible for an architect to draw everything in a building. And so that's why architects' contracts always say something like, the architectural drawings represent the design intent. The contractor is responsible for coordination of specific elements that are not clearly identified. So, so what you see here is, this is an RFI, which is request for information, RFC, request for clarification, SK is a sketch, and field instruction is, if you are out in the field and you give an instruction, it must be recorded in the form of a field instruction, which is a standard form. So here we have RFI number 12 for the bioswale at Congregation Beth David, and you see that my senior project architect responded here, please see SK 41 regarding this, and it was drawn on January 8th of 2016. So here's SK1, oh, it's SK1RE, drawn on January 8th, 2016, and it is a drawing of the bioswale that was meant to answer specific questions. There was quite a bit of research behind this because we needed a specific square footage of bioswale, which is basically a sort of a ditch that's all planted with beautiful green plants. You've probably seen them without knowing it, but it's something that's designed to absorb contaminants from rainwater runoff. But you have to have a certain square footage of it in any given project. So, so that's an RFI. These, because they clarify and they draw specific elements that were never covered in the architectural set, as I say, you cannot make a legal case without knowing everything that is in this RFI, RFC, SK, and field instruction log. And typically on a large project, each one of those will have its own log, and they will be tracked whether they've been answered or not, and whether the answer was sufficient or you need to resubmit. That's actually probably why this was called 41RE. It was a resubmittal for additional information on the bioswale that was requested. So what you've learned today, I hope that you have gotten something good out of this, and I'm going to give you both Eugene's and my emails in a moment, and we would love to hear from you how you felt about this, what you felt you missed, and I'm going to be here for 30 minutes following this presentation. For anyone who has a question, you can unmute yourself and ask a question, and I'll refer to the appropriate slide. But what I wanted to try and convey was so that you can understand the phases of design and construction, a basic understanding of what a plan, elevation, section, and a detail is, how to understand what they are and how to read them, what are details and their importance because that is so critical, then how to navigate through a set of architectural drawings from one end of the drawing set to the other, drawing index and how to understand differences in the sections, how to navigate through a set of drawings to find the detailed drawing that you need, reading the specifications, the CSI format. So there are several subsequent sessions here that are available. We haven't scheduled any of these, but there's a seminar on the architect's standard of care and what it means to you attorneys in the construction litigation field. There is a seminar on each drawing type in much closer detail so that you can get a deeper understanding of the issues raised in the very close detailed drawings. What that requires is a lot of knowledge about what all of the technical representations of the various building materials are. So you need to know what insulation looks like in an architect's detail, or what building paper, or what roofing material, or vinyl tile, what any of those materials actually look like, and what the rendering convention is, so that you can identify them. So thank you so much for joining us today. Here are my email and Eugene's. I don't know why mine is a live link, but it won't be when you get the, you'll get a link to this whole presentation that you have available to you. And I see that a lot of people have been asking questions, so I will start to answer those in a moment. and you can contact either Eugene or myself. I'm happy to offer advice, take a look at things. I typically won't do a full-on review of drawings without a contract with you, the attorney, but feel free to email questions. I'm happy to help where I can, and I hope to hear from you, and I hope to see some of you back for the subsequent sessions. So thank you so much. Really appreciate you being here. Have a great day. Okay. So somebody asked, will this presentation be posted for review? And yes, it will. As I said, I believe Jeff or Eugene, one or the other of them, will send you a link to a page on the Advise and Consult website, which will allow you to link directly to this whole presentation. And if there's something in specific that you need or something you want to ask a question about, feel free to ask me about it. Gabriella Wagner, thank you. I really appreciate you being here. Thank you. I hope you learned something. Questions? Oh, thank you, Eugene. Thanks, everybody. Thank you. Thank you. Thank you for that question. I assume that your names will be kept on the email list. I don't know when the subsequent seminars will be scheduled for, but yes, of course, you will get an announcement of those seminars as well. And I hope I will see you, Heidi. Thank you.